Welcome, everyone, to the ASPRS Mentors Podcast. My name is Greg Stamnis, Chair of the ASPRS Early Career Professionals Council, or ECPC for short. We also have with us Jordan Hicks, Vice Chair of the ECPC. Jordan, do you want to introduce yourself?
Yeah, thanks, Greg. I'm Jordan, and I'm a vice president and a LiDAR specialist at a company in North Little Rock, Arkansas. I'm really excited to hear from our guests today. Thanks.
Thanks, Jordan. Our guest this week is Florent. Florent, are you okay with us recording this meeting and sharing it on various platforms?
Yeah, of course, of course. It's open knowledge.
Perfect. I guess we'll get you to start with introducing yourself and sharing your journey of how you got to where you are now, I guess, the field of 3D reconstruction and geospatial science in general.
Essentially, what I'm doing today is building stuff, right? But things around 3D and geospatial information to solve challenges. So let's say that's called innovation. That's a bit tricky compared to research, but that's applying really all let's say the years behind to try to solve stuff that were making us in a bad position in various applications. And of course, along the way, while I can, I educate as much as possible. So I share whichever finding I have, or among consultation, I will give my advices about how to solve such or such situation. To get there, I guess I was like anyone else. I just started. I was a bit lost after, I don't know what it's called for you guys, after 18 years old. Just, is it college? I'm not
Yeah,
sure. Okay,
yeah.
so entering college, and after going into university, I was not sure. I knew I liked logical stuff, and was always fascinated by spatial phenomenon. And the first thing that triggered me was like, oh, that's so cool that you can create a house from just designs and ideas. And that speaks for itself. Then I investigated architecture, and I wanted to become an architect. So I went and I saw a friend of my father, and he told me that's the worst idea possible, at least in France. The market is crowded, and it's very, very hard to make a living out of it. So if you like to be around that, just consider maybe look at surveying. That may be something for you. So I Googled it, and I remember seeing this géomètre expert, so land surveyor, and was like, oh, that sounds very cool. And yeah, I've built my portfolio. I went into the engineering school. I did a half a year, I think, in Calgary, in the School of Geomatics Engineering as well. And yeah, got my diploma and started working to have my own practice. But here, I was really fortunate to be in a small surveying office where they had a lot of knowledge around laser scanning and drones and things like this. So I picked that up really quickly, started creating partnership in Europe with some companies to grow the things around 3D scanning. But here I was always annoyed by the thing that I think you already know, but you get this magnificent point cloud, and I'm speaking, that's 15 years ago almost, so amazing point clouds, and nothing to be done with it except just redrawing everything line by line on AutoCAD, trying to extract some kind of floor plan or map for professionals, and it was really bugging me. So this is where I started. I had a friend with who I did my engineering thesis, and he called me and he asked me if I wanted to teach at the university in Liège. I said, yeah, sure. And I would do my PhD alongside. So this is what I did. And I pushed a lot this idea of, instead of extracting deliverables, just making that automatic and rezoning. So injecting AI within point cloud directly. And this is where I did this smart point cloud architecture. That led me to Germany to do a postdoc for geometric deep learning, so trying to inject even more their AI, let's say. And after that, going back to teaching at the university as a professor, and now trying to do that, but for professionals. at any stage in their career, because there is nothing at the university, at least in Europe, that can help you when you are an established professional. If you do not want to get back to the university for 5 years or so, there is nothing existing. So I was thinking, okay, let's try and help that what I can, and that's what I'm doing. So essentially, this is really opportunities and having ideas about things that I was stuck with and trying to build solutions to that. So yeah, this is me.
That's awesome. Yeah, it's fascinating kind of how your story is similar to a lot of our previous guests. We always think that people have like laser focus on where they're headed, but it kind of, I mean, you started with a Google search. So yeah, it's fascinating. During those early years, what were some of your challenges you faced in the digitizing and automation process that you kind of identified and wanted to focus on?
Yep. Yeah, I think so. There are 3, maybe 4 that come to mind. Some of which are obvious, like data quality. I focus mostly on point cloud, but yeah, having accurate and consistent data, that's important, and methods for that. Computational power, that was also really a struggle. I mean, that time, like processing billion points in a single file, that was super annoying with the hardware at disposal. But we had to create some dirty tricks to solve that. So it was not really like it was not brick and mortar. That was really matches with glue that we were trying to do. That was a big problem. Then algorithm development as well. In the early stages, I knew really little about coding. So this means that I was mostly engineering solution, taking a bit of this software functionality with this one and this one, but at any point you have 20 softwares, the licenses that go with it, and you are still limited to what you can do. And the last thing would be the deliverable. So how productive you can be whenever you have your raw data and you push that to clients. This was really taking too long. And that's really was like the lightning on the match that pushed me to go into research. Yeah.
So kind of around that time, you were making a decision about what programming language you were going to kind of focus on. How did you navigate that decision, and what advice would you give to those in similar situations today?
I mean, my experience when I first started really taking things seriously on the coding side was like 10 years ago at the beginning of my PhD. So things are moving pretty fast. But the essentially, I think the most important stuff, at least for me, was to have something triggered by my needs. I just wanted to build a solution, and then okay, I want to integrate like semantics and something smart in point cloud. How can I do that? And that was the starting point. And then because I had the time with a PhD to investigate a bit more, then I picked up a programming language that was good with AI, because I knew I needed to do something with AI. At the time on 3D, it was absolutely new. So I was one of the first, let's say, to integrate that into 3D data set. So naturally, Python was the language I went to. I investigated some others, but essentially today, I think looking at community support, the library ecosystem that will give you a lot of time on your hands if you have a lot of cool libraries, and also the learning curve. So having something that doesn't take too long to get into. For example, C++ has a steeper learning curve than Python, but you can do things much more powerful. But again, you have to handle the interaction, what's happening with your GPU, where you store your CUDA core, things like this. I will avoid that. At first, you can still go there at the end, but yeah, Python will be my recommendation for starting. And if you are feeling like a geek, I really love Rust, which is another language, but it's hard to mimic what you can do in Python in Rust. but it's much more powerful and let's say secure.
Awesome. Very fascinating. Haven't heard of that. I might check it out as a geek. So I guess switching topics slightly, how do you see generative AI enhancing traditional structure for motion and photogrammetry workflows? And does it improve the accuracy or efficiency of structure for motion?
So at the time, maybe, but very little. So I think there are three main, like for SFM at least, or for photogrammetric workflow, there are three main tasks in which AI started to be injected, like with good results. It's the first one is feature matching, having two images to match. You need some features to match them, and traditionally you use like some feature extractors, classical computer vision techniques, but now you have the ability to use deep learning models that were trained to pick up very crisp feature, and there are some that are pretty nice. So this is one thing where I see that it's not generative AI, but it's AI at large, let's say, so deep learning. Pose estimation as well, having the ability to like get the pose, the position of each image relatively to one another and relatively to the world. This is something that is traditionally done with SFM, for example, or multi-view stereo. That can be done with other methods now, AI-based. Depth estimation. So this plays on generative AI, like from a single image, monocular image to depth. Take an image and you infer how, like the Z direction, how far a point is from your single image. This is something very strong. You have some cool model. It started with Midas, and then one that I like is Depth Anything. Now you have Depth Anything V2. And just, I think this week, Apple released its own version of depth estimation as well. So there's three examples, but that's mostly modular blocks into the pipeline. So essentially, what we can get from that is playing on speed. Like you want to have the reconstruction quicker, more accurate. For now, there is not a single framework that allows that, and resolution. So trying to have something at higher resolution. This I started investigating, like you upscale your images before using them for matching through photogrammetry, for example. So you upscale with Gen AI, and you could think that you will get a better reconstruction, but no, actually you just get a mess, because the sharpening or the upscaling just pick up unnatural features. And this is one super strong point in our community. We deal with real world data. Generative AI is like not real world data, that's inferred data. So this is very, we have to use that cautiously, but it's super interesting. Yeah.
So what role does it play in the future of 3D content creation, particularly in automating and stylizing 3D models?
So yeah, I think the first thing is, so that's my view, is it's super useful to for data augmentation. Whenever you train some kind of models, you need a lot of data. And if you have some ways to create synthetic data with automated way, like with Gen AI, it's basically a nice loop, positive loop. So that's one cool stuff. It's unclear as of yet where this is going, but I can see for entertainment industry how powerful that can be. It's like you develop a video game. If you are just having an idea and you type something like, okay, create a world with a mountain in the back, then in front I want a mill and then a house. Okay, it will create that stuff, and then after, oh, now insert three people in it and take some trees and a magic forest. All these things can be done today with some procedural modeling, right? But it doesn't play so much on you are still limited to how the algorithm was designed. With Gen AI, you can also leverage a bit what we call fake creativity, right? Where you will be able to put things that you will not have thought or which wasn't designed in the algorithm. So this is, I think, something that could be super powerful. But then again, it's hard today to have good quality when you use that for 3D. Usually it's a bit messy, the meshes that you get or the texture. The realism is not super sharp, and you have limited like control on the customization aspects of things. So there are things that I know some companies are working on, but yeah, I think it would be quick to have that fixed. But for geospatial, this is a bit more complicated because of this real world aspect of thing. Yeah.
So I think Jordan got into the questions here and added a few. So can you talk about some of the Python libraries and tools that you regularly use to automate tasks?
Yeah. So basically, I have two main branches or three main branches. So I have the core libraries that I always use. This is like NumPy, SciPy, Matplotlib. That's only three. You can use Panda or GeoPandas, but already with S3, you can do pretty much everything. Of course, to like get on with AI, you have to inject PyTorch. I would not recommend TensorFlow. I've built stuff. I had team built a lot of very cool stuff with TensorFlow. Now it's too, yeah, you have to go too deep to have something that is working. It's not super stable. So PyTorch is the go-to library for AI today. If that's a bit tricky at the beginning, you can start with Keras, which is a cool one. There's a lot of wrapper basically. So you will use a model very similarly to the last library that I really like for machine learning. It's scikit-learn, right? So that NumPy, SciPy, Matplotlib, scikit-learn, PyTorch, and what else did I say? And Keras if you need. And that's pretty much it. And for 3D, you have Open3D and PyVista. These are two very cool libraries that allows to do a lot of stuff as well. So yeah, with that, you're good to go.
I have a follow-up to that. I think you touch on this somewhere in one of your YouTube videos or somewhere. I must have seen it, but what is kind of the minimum hardware you need to start using like machine learning with Python? Like, is there a minimum requirement there for CPU or anything like that?
Yeah, there is, but there is also not. It depends on the approach. Let me clarify. So in general, if we look at data at large in Python today, you can basically develop anything with cloud-based technology. You can spin off a Google Colab or other IDE online, and you will leverage server-based resources that are not tied to your computer. So this is something very handy, for example, for Mac users that do not have an NVIDIA GPU. Whenever they need to train something, they will leverage like outsourced GPUs. And you have some free credit with Google as well for 1 hour also. But if you're serious about creating and building 3D geospatial solution or 3D spatial AI at large, I highly recommend that you get your hands onto a local setup. Because of using 3D, we play a lot with OpenGL and graphics. So like you will work in a breeze locally compared to what you will have with a server. And on top, with a server, you are usually super limited with visualizations. So you cannot iterate very quickly. You have to always download the data, open it in a local software. But still, that means that you need to have some kind of hardware that can handle that. That means that for local development, I think having CPU is not really an issue. If you get an i7 for Intel or a Ryzen 7, that's very good. and above, of course. For like space, so hard drive, if you can get a 1 terabyte SSD, you are in a very good position. It's not mandatory, but that allows you to play with big data set and such in a fast manner. And for the RAM, I would advise 16 gigabytes and above. You can get with Flora, but 16 will allow you to do a lot of stuff. And if you are serious about going into 3D deep learning, then you will need a GPU. And in here, take a very good one. So NVIDIA, of course, with CUDA core, like an RTX 3090, 4090, that's the best. Or you have better, of course, but that's already super expensive. Else, you will do like most of the stuff with a 3070 or 4070. And I don't know if right now there are 5070, but yeah, this kind of series are good enough.
Perfect. That's great. I'm kind of mapping that out myself, and then I stumbled on that video of yours and a few other resources, and I'm like, I don't know what to do. So, how can professionals bridge the gap between knowledge and skills in deep learning and 3D processing? And what resources would you recommend for those looking to deepen their understanding of AI in 3D scene analysis?
Yeah, I mean, this is very tricky. If you start in the going into a hole, a rabbit hole where you fall and you don't know which line to take, or you start taking a line and you're like, oh crap, there is this other one that looks super cool, let's go there. I think the most important thing, or to make things super easy, is if you can ideate a project that seems feasible that you want to achieve. That would be the red line for me. And having that, then just building knowledge based on that. So it's project oriented. This is how I've used to teach at the university for more than 10 years. This is where I saw students like really pick up stuff and create actual solutions and not just ingest knowledge and then forget about it. So that will be the red line. Now, online with the internet at large, you have pretty much everything accessible for free. It's just sometimes really a pain to find good resources, communities, things like this. So let's say you have 3 or 4 main buckets. So you will have everything linked with online courses. Either you're really clear about your map and you can do that alone, and then you pick up all the courses and you try to follow that. But usually it's hard to have that follow your red line. Then you have tutorials and documentation. That's often very cool to make sure that you understand the concept before moving on to some kind of paid solution. You have research papers. That's where you need to go deeper, but that's also very important to do. And then you have all open source projects. So essentially GitHub, picking up a repository, replicating, and then extending from it. My recommendation with all of that is really to go into a clear manner. So first, principle thinking, that's essential. Then you build, then you optimize, then you deploy, and then after you automate. So not the other way around. I've been there, and that's a horrendous error. It's really important to make that in that order. So yeah, that's how I will go around and bridge this gap. And of course, but here I'm not impartial, because this is what I created, the 3D Geodata Academy. Like when I design all the courses and the tracks, this is what I took care of, making sure that you don't need to switch anywhere else. You just pick it up, you follow, and at the end you have everything that I've listed. So the project build, the 3D deep learning stuff. So yeah, but again, that's something that I cannot, without saying that I create that. So yeah, of course I'm not objective there.
So can you talk about how NERF and Gaussian splatting are changing 3D visualization and how they compare with traditional approaches?
Yes, of course. We are really early on, but again, that moves so freaking fast that it's very important to keep an eye on how things are going. It's essentially what you mentioned. I think the word 3D visualization is super important. This is not 3D reconstruction. This is indeed 3D visualization. So for geospatial communities, 3D visualization is really one aspect of things. And it's very important, but what is like, at least for professional, what is really the core is making sure that the data is accurate, you can reason it, it's well structured, it's well accessible. And visualization is like the cherry on top of the cake. And in here, Gaussian splatting, I guess you've seen the rendering, it looks like almost magic. You start by first picking up like a drone path, and you pick up the videos, and then you have the Gaussian splatting. So initially you're like, yeah, what's the point? Because you can have that with a video. But then when you understand that you can move around and that you have actually a point cloud underlying, and it's just a method to represent the points themselves, it's really, really nice. And I'm especially fond of this kind of methods that actually do not interpolate per se, like meshing. If you want to turn your point cloud into a mesh, you have to interpolate, you lose some kind of accuracy. With Gaussian splatting, essentially, the base is a point cloud. It depends as how you create this point cloud, but it's a point cloud with a set of images. So this is what I love, because I'm super, super in love with point clouds, of course. And here we still are based with point cloud. So this is the main data representation, and you can do so much with that. So I think benchmarking this kind of approach against others needs to be done with care, but on the 3D visualization aspect of thing, we can expect great things from it. And we already see some big company picking it up, like Meta or things like this.
Do you see any practical applications emerging from those kind of visualization techniques, or specific industries or use cases that are well suited for them?
Yes, so I've been working on some product for some companies using that past year, and I cannot, so let me just filter out what I can and cannot say. So yeah, there are two that I can say at least. So one was for a marketing company that wanted to provide very quickly to shoe designs, very quickly to the shoe designers, and have a back and forth exchanges. And after when things was validated, they could just create the model, create the Gaussian splat experience, and put that to the market, to the customers directly. So this is very, very cool project, very far away from what we are used to, but that's where for now there is an interest into this kind of marketing online stuff, basically trying to have anything that you want to sell physically, but you need some kind of 3D rendering. This can help a lot. I've seen also, and I've developed a proof of concept for a company that then created a spin-off and a nice startup based from that, where you basically scan motor pieces just with your phone, and then you create some kind of Gaussian splatting experience that then you will use into an AI engine that will be able to pick up much more precisely than with a classical photogrammetric pipeline or photogrammetric rendering. Will pick up much better all the elements in the motor and match that against a database of pieces, and know exactly, and will be able to tell you this is this piece. And this is super useful in a production line. So that was for a production line of a big car manufacturer, and this is now in production. And that's crazy, because the Gaussian splatting is like in itself, it's very old Gaussians and putting point as Gaussian. But in here, it's like really the architecture that is used is less than 2 years. It's already in production. So this is tricky. I could do that because I knew it was not on a critical point. We had backlogs and we could switch the module by something else. So if this was failing, we could go through another direction. But for young professionals that are excited about new stuff, trying to put that right away in production, I think that's the recipe for disaster. So yeah, usually we had, before AI, we had like 20 years of backlog on a specific algorithm or technique. So we know everything, the limitation and such. Here we have a black box. It looks super cool. We put it in production. So this is really dangerous. Yeah.
Yeah, I think that that can be a common pitfall of people is taking things a little too quickly and then implementing it with like a client and then leaving a bad taste in everybody's mouth, and it kind of limits the adoption of new technologies when that happens.
Yeah, exactly. Yeah.
So yeah, I heard you say Geodata Academy. What is that? Is that like a secret society, or what exactly is that?
Yeah, it's like a gang of gangster. No. So it's something that I actually was not essentially sure about. So I was still a professor at the University of Liège at the time, and as I mentioned early on, I was getting asked every day about companies. They were asking me to do consulting, and they were asking me to help them on such or such project, and they didn't know where to start. So I searched the web again, and nothing popped in. So I was thinking, okay, let me try to bring that knowledge to the professionals that need it to build new stuff. And this is where in 2021, I think I created the academy with the first course on 3D reconstruction with photogrammetry. The idea was to start with a camera, and I was taking people from there up to the ability to sell 3D model as assets online. And that was a huge success. And people were actually creating startup from that, either building a solution that does that or selling as a service their what they learned. That I continued with a point cloud course, where essentially was taking people from, okay, now you gather point cloud, how can you process them? So register them, clean them, or you extract feature, or you extract some semantics, or you create labeled data sets and such, and how you play a bit with machine learning, more with an engineering perspective. So without too much Python there, was mostly being smart about it. And moving on, I built more courses tailored to the needs that people were having. And now my mantra, let's say, is learn, build, ship, and market. So innovating in 3D is first you learn, then you build, then you ship it, and then you market it. And for that, you have a specific course line that really allow you not just to inject knowledge, but to have hands-on knowledge, so new skills that you apply directly and create stuff with it. And this is fantastic because working with professionals, of course, I'm always invested with everything. So people mail me, people write me on Discord and answer questions. And sometimes I take people on one-on-one calls. And when they show me the problem they have, I've never heard of that. Like I had this guy that was working with brains of little insects, and he was representing that as point cloud, and he was thinking, how can I use the course to do that? And I was like, oh crap, I didn't thought of that. But yeah, actually you just had to switch that, and that works. You will detect all the little synapses and such. I had this guy that works on ships, and he needed to like compute the volume of some kind of weird cube, and someone that want to simulate tree growth. So kind of applications that I've never heard of or I've never seen before, and it's always like I think I learn as much as the people in the courses. That's why I love it. This community of professionals, everyone is an expert somewhere, and taking this knowledge together, that's beautiful. So in this sense, it's like a gang, yeah.
How many courses total are there? 5?
Yeah, 1, 2, 3. So I think there are 9, but I'm packaging. Yeah, so you have 2 options. You have the option, if you really know what you're doing, to just take one single course for one specific problem. But if you are starting, I created course lines, and for now there is a 3D segmenter OS. The idea is you start from scratch, you learn Python, you learn perception, 3D perception, detecting stuff. Then you learn to integrate AI a bit, extracting semantic segmentation, and creating an application that allows you to ingest a point cloud and spit out anything that your Python program does in the backend. So that's one big track, and the other one, which is much steeper, is 3D deep learning. This is really focused on deep learning. Is if this segmenter fails at the metrics because of the semantic segmentation approach, for example, you want to upscale that, then we may need to move into 3D deep learning. But for that, you need a course to understand. It's not like 2D deep learning, just adding a dimension. It's really, you change the data representation, you change the paradigm about how you process stuff. So this is the other course line that is there. And I'm working on the last one since like July, which is 3D reconstructor. It's one course for now, but the idea is that I want to have the early pipeline with automation, and like, okay, you take images, you create a store, but I want to expand that with LiDAR, with SLAM, with injecting AI early on to have something really, really precise at the 3D reconstruction, spatial AI, and 3D perception, yeah.
And so would you consider it a good resource for our target audience, like early career professionals, or is there other, like, who's the target audience for the courses?
Yeah, I think if you can identify to someone that want to create with cutting edge tech, so 3D tech at large, that's perfect for you. So the levels, I have people that are master students, I have people that are 60 years old and that are leading big tech companies. It's very wide. What I can say is already all the GAFAM are there. So I have engineers from Google, from Meta, from Airbus, from all the big companies that they need to learn this stuff, because I mean you cannot. It's very weird. You cannot have it so easily on the web, or you have GitHub repositories done by researchers, but then you have to have a bit of luck to understand what's happening, how you can make that work for your computer and such. And there's also stuff, for example, that with Jean-Jacques, which joined the academy beginning of the year, which has a PhD in AI. We are taking some time, like 8 months, to recode a solution and push that as part of the course line, so that the code is also available and very easy to use, speed and such. So if you are early career, I think that's perfect, because you can pick it up from 0 to 1. Without Python knowledge, you pick it up and then you build something at the end, and you have something to show for your portfolio or to your boss. If you're already a well-established engineer, that's super cool to optimize your process or automate your process. And if you're a researcher, then it's mostly the 3D deep learning course that is super pertinent there.
What excites you most about the future of 3D reconstruction, automation, and visualization, and what should young professionals or professionals alike be paying attention to as everything continues to evolve?
Oh man, that's a whole. I need to to put my thoughts in because there is so much exciting stuff there. So yeah, I think one of the foremost aspects that is yet not touched is a real-time 3D capture. So this is possible with laser scanners, but as we move more and more to passive sensoring, like image-based reconstruction, there will be one time where you will be able to just with a single camera get a real-time reconstruction. You can get a real-time depth reconstruction. This is something that we do as part of the course line, for example, but you cannot get a full like scene like the room in which you are or outdoor today. And that is something that I think is super exciting. Then you have everything linked with AI-driven automation. This is something beautiful. I love to automate stuff in everyday tasks at large, but for 3D especially, you have a lot of potential to leverage that. So I think that's very important as well. What else? Yeah, I've been speaking about 3D, but of course, we have a lot of modalities with spatial data sets. So we play with raster and vector, that's the basics, right? But you have other sensory inputs, and I always make the parallel to our perceptive cognition system. We have our eyes, we have our brain, and we act. And this is essentially what we try to replicate. And why 3D is key here? Because it unlocks spatial AI and the ability to perceive and reason and interact with the environment like a human. And this is so exciting. And everything that I do goes in this direction, or what I teach goes in this direction, having the ability to create stuff that can mimic in a way what we can do. But that's super, super, super complex. There are a lot of little details that we need to address. And this is something where I think we'll have a lot of evolution, but we'll not see that in 1 month. Oh, boom, everything is solved. There is so much to be done at the eye rolls is already a big stuff, but the brain is the bigger stuff. How can you have a computer behave like a brain about what he's sensing? So whichever data feed you give him, how can you make sense of that? So this is a big stuff. We still have to be very, very considerate about ethics, especially with data privacy and bias. This is something I've seen, and we've seen a lot. If you look at the numbers, you will have, I don't know, a ratio maybe of 1 to 1,000. That's not the real ratio, but there is a huge gap into the number of researchers that works on AI models versus how many works on ethics consideration of the use of AI. So that's a big problem. And especially with 3D, it's not just an extension of 2D. So that's something to take into consideration. And yeah, maybe one last thought is that this, whenever you think about how you perceive the environment, and maybe I can relate or give an example with the way I'm talking right now, right? So I have a mental model right now in my brain about something that I want to convey, a mental map, and then I compress that into English words. This is not my maternal language, so of course that's also the compression is not lossless. There is a lot of things that are lost, right? And then it arrives to your ears and to anyone hearing that. And my goal is that you can decompress that and have the same mental map that I have. So this is decompression, compression and decompression. This is exactly like what people are trying to do with transformers architecture, encoder, decoder. And if you start looking at anything related with AI, this is really trying to mimic whichever behavior that we are having in real life. So this is crazy how much the creativity is really tiny, actually. It's not like super original stuff, research today. It's really like observation, replication for a computer. And this is fine, and this is perfect. I mean, I think it's just a matter of building solution up to a certain point that you can test it and you can get some kind of new things and iterate. And I love that about innovation, this cycle of you're just working somewhere and you have an idea that pops up, and if you are quick enough to write that down, you can try this idea and iterate. So those are things really worth considering. And if I can digress even more on that topic, it's very rare that actually one thought that you are thinking for 8 hours is the good idea. Usually it's the idea that works in the background for 1 month and that pops up, and that's the first idea, and that's the one that you should explore. And this is fascinating because the way the brain work offline without us knowing, but is doing stuff, this is really fascinating whenever you deal with deep learning and 3D deep learning at large. That's really, really far from, we've spoken about AI, but we are so far from AI currently. But it's so cool. So yeah, I stopped digressing. Yeah.
So we're still in the infancy of the evolution of AI and deep learning. I find it fascinating how maybe it's kind of the same as your story. You're talking about you started out in industry and people were taking point clouds and digitizing into CAD models. And so they're taking all that information and essentially like throwing it out. And that's kind of how the commercialization of creating CAD and BIM has been, get rid of the point cloud. Maybe it was a limitation in hardware, like you said, 15 years ago, that they just wanted to get rid of it as fast as they could to create the CAD and the BIM model. It's fascinating how you've kind of taken a step back and looked at it and said there's a ton of value here, and we should still be using this to create 3D objects. Do you think that there's going to be like a convergence again, like when, say, you're doing your 3D object segmentation with point cloud and kind of classifying it, and then using machine learning to turn that back into the CAD and the BIM models?
Yeah, I mean, I think it's a bit utopist to think that we are going to change the methodologies and the workflows established for years within large companies in a matter of 6 months or so. This is something that I've experimented early on. For example, whenever I was at this company, I created this other startup that allowed you to essentially have point cloud online. And the idea that I had at the time was like, okay, I'm annoyed to convert point cloud into CAD. Let's deliver that directly to architects. And at the time, like people like were amazed by, oh, you have this kind of data set. That's so cool. But yeah, can you do such slice or give us some so it was too early. Now it's getting in that you can use point cloud directly within a lot of softwares, even ArchiCAD, right? Or BIM, Revit, sorry, or any or AutoCAD as well. So this is integrated, but still the valuable deliverables is a 2D CAD map or a 3D BIM model. So that means that in the time being smart about using the base, doing everything on the point cloud is the best solution. You have that as a central hub. And the only thing is you have one click that says, okay, now take the semantics, take the various objects, make that Revit families, and assemble all of that to create the BIM model and deliver that to the client. So this one button does not exist yet. Some companies are working on it. But yeah, I think that's the way to go, trying to work at this stage on the processing, like delivering the same value, but with a different workflow essentially. And as time comes, and depending on clients and feelings and such, it's very likely that the value of the point cloud directly will make a lot of sense. Oh, but why do I use that when you can have all of it on the points themselves. And Gaussian splatting could be one way to convey clarity whenever you want photorealistic stuff without going into meshing, for example. And game engines pick that up. They already injected Gaussian splattings as part of their workflow, and some creative people use that in After Effects to create videos as well. So things are moving more in the industry that are used to moving. The construction, we are a bit slower. In geospatial, we are a bit slower. So it will take more time, but yeah, I think it will come at any point.
Perfect. Well, that's all I got for you today. Thank you so much for taking the time to meet with us and share all this information. If anybody wants to get in touch with you to learn more or dive into the Geodata Academy, what's the best way to get in touch with you?
The best way is through the Academy. Either you have my mail there, or if you get onto the newsletter, I send it from my personal email, professional email from the Academy, and you can write there. That makes me think that I'm almost finished writing a book called 3D Data Science with Python. So that should be interesting for a lot of people. And I wrote that with O'Reilly, which is my favorite editor. This little animal book. This is fantastic books. So I'm super proud to write a book with them on 3D data science with Python to build spatial AI systems. 17 chapters. I'm just finishing the 17th. People are on the tech review round right now, and then after it goes in production. So it will be for early 2025, but I can officially say that it's coming. Yeah.
Awesome. Well, thank you so much for sharing that. I'm sure anybody who watches this will pre-order a copy, I'm sure. So thank you so much.
Super. All right. Thanks a lot.